Hi, my name is Jolie Benton, and this is my breadboarding project for iTech 7485. The goal of this assignment was to create a working breadboard circuit that used the microbit to control real components. The circuit needed two inputs and two outputs, and at least one of each had to be connected through the breadboard. Finally, we were asked to record a short video of reflection explaining the build and upload our MakeCode project link to D2L. Here's my circuit diagram. I use the microbit to connect three components through the breadboard. The photoresistor on pin 0 acts as a light sensor input. When the light level drops, the microbit sends signals to pin 1 and pin 2. Pin 1 powers an LED, and pin 2 activates the buzzer. The 3-volt and ground pins provide power and ground to the entire board. This slide shows my MakeCode program. The program continuously reads the light value from pin 0. When the light drops below a threshold of around 450, it turns on the LED and buzzer. When the light goes back up, it turns them off again. I also added button A event that resets everything, and I disabled the built-in speaker so I wouldn't get the 521 error that appears when both speakers are active. One of my biggest challenges was figuring out the correct polarity for both the LED and the buzzer. I kept getting mixed results at first, and it took a while to realize that even one reverse connection would stop the circuit from working. I also ran into error 521, which made me think something was wrong with my code, but it actually came down to my wiring setup. To fix it, I verified my pin mapping through testing and disabled the built-in speaker on the microbit to avoid interference. Another small but frustrating issue was not having enough jumper wires in matching colors. It made it harder to trace power and ground connections. I learned to slow down and check every wire carefully, which helped me understand how each part connects and communicates through the breadboard. By the end, I realized that most of my errors were just learning moments in disguise, and every fix helped me see the logic behind the hardware a little bit more clearly. This project was definitely a learning experience for me. It actually took me about 45 minutes to an hour just to identify every piece in the kit and figure out where each one belonged on the breadboard. When I finally got everything in place and powered it on, I saw the heart icon appear, and I literally shouted for joy. That small moment made all the time and confusion worth it. Even though my circuit never worked perfectly, I learned so much about how each part functions and how code, wiring, and power all come together. I also realized that I'm probably not meant to be an electrician, but I really value the experience because it helped me understand how physical computing actually works.